Yes, I'm cooking for my son and his wife. It's his 30th birthday. 4 days into my bowl at the milk of 2 months ago. It's more than mom, isn't it? I don't give a flying fuck about. It's fruit nouveau. It's fruit nouveau. The shape of love. Love is sweet. You were born in the 60s. We made the war with the Vietnamese. We love LC, we die easily. Can we just say, shut up? So what, for your own sake? Do you have a headache or a heartbreak? I'm broken by the birthday cake. You and me so on the uptake. I put a pot in the birthday cake. So what, for my own sake? Watch out, yo, here come yo. I'm gonna change your rattle sake. Turn up the TV, do you agree? Yeah, I'm talking turkey, take it from me. I'm gonna show my love for my dad, but it's more than mom, isn't it? Extra sugar, extra salt, extra oil, MSG. Extra sugar, extra salt, extra oil, MSG. You know my love is love is very sweet.
Okay, so welcome back to everybody online, hopefully. Just to review what we were doing before the break, we were covering databases, and we had gone through an entire tutorial on creating this database to support the account management system that we had created in Java. We've got an account, an annuity account, and a savings account. And just to take a look at what these look like, again, remember that we've got a savings account whose value is a balance. We've got an annuity account that pays monthly payments for a certain number of years, and there are 12 months in a year, so that's the value of an annuity account. We did this in the database by creating 4 separate tables: person table, account table, and then we brought these together. So it was a little bit of a different design in that we allowed one person to have multiple accounts, but also one account now has multiple owners. And then of course we've got the email table over there. So I wanted to go through and review some of the make some of the observations of what we did when we did that database design. In particular, just like object-oriented programming, semantics dictate design. Usually you have one entity per table, and so if you take a look at, here, let me go ahead and zoom in over here a little bit. There we go. Over here, it's not a clean mapping, but certainly we have a person table over here corresponding to the person object over here. Right? We have an email table over here. Even though we didn't have an email class over here, we could have if you really wanted to, but it wasn't necessary. It fell under Yagni. You ain't gonna need it, right? Instead, we have a list of strings to indicate that we've got a one-to-many relationship between a person and an email. One person has many emails. Then we've got an account class. We've got an account table over here, and over here, what we have is an account, an annuity, and a savings account. That's because we followed a single table inheritance strategy, and we'll review that here in a moment. But otherwise, semantics dictate design, right? That there should be a nice, clean one-to-one mapping from your database to your Java objects, your POJOs, your plain old Java objects. Some style tips, right? Be consistent with your naming conventions. This is exactly the same as in Java. And in fact, the suggestion that we use is to use Java's naming conventions, right? That tables should be upper camel cased, right? Upper camel case. That columns should be lower camel case, right? And the reason for that should be pretty clear now, because there's going to be a one-to-one mapping from our Java objects to our tables, and in our Java objects are variables to our columns. So if you use the exact same naming conventions, in fact, the exact same names for a lot of these things, then it takes a lot of the guesswork out of it, right? And just like classes, avoid pluralizations, avoid abbreviations, unless it's absolutely clear what you're talking about. Make sure that every table has a primary key, right? So that's primary key, not null, auto increment, right? And name it, right? After the table, or the table name plus ID, right? Why? Because again, a consistent naming convention will mean that there's no guesswork with it. For example, person ID or email ID, right? And if you know the name of the table, then you immediately know the name of the identifier, the primary key in that table, if you're following that naming convention. Why do you want to make sure that everything has a primary key? Because it gives you second normal form for free, which is what we'll talk about here at the end. We'll talk about database normalization and why you want to do it. Foreign keys should have the same name as the primary key that they reference, right? So for example, let me bring that over. Let's go back over here to the ER diagram. How do you know that this email is owned by what person? There is a foreign key in here called person ID that references the person table, and within that table, it references the person ID within that table. The names match, right? Now you don't always get that because sometimes you have to make more than one reference to a table. For example, in your project, a sale or an invoice has a salesperson, a customer, and is that it? I forget. But anyway, you've got two things, right? You can't use person ID. You'll need to be more descriptive on that. But otherwise, person ID over here, account ID over here is the same as the person ID over here and the account ID over here, right? You're following the same naming conventions all over the place. And so foreign keys should match, have the same name as the primary key. Strings, in other words, varchars, should not be used for primary keys or foreign keys. There are casting issues. There are encoding issues, or that's not casting, it should be casing issues, right? Uppercase versus lowercase, do they match? There are encoding issues, and of course there's efficiency. If everything is an integer, it's super easy to compare this integer to that integer, and it's exact. But if you've got a string and that string, now you're talking about string comparisons, all right? And you could have 1,000 characters or something like that, versus just 4 bytes of comparisons. So avoid those, right? Now, I'm not saying that they can't be keys. In fact, they should be keys, just not primary keys or foreign keys. Join tables should be used to model a many-to-many relationship. Be sure to insert plenty of test data into your database, right? In fact, you're going to be required to do that for your project on this next phase due in about 2 weeks. Remember that when you did the first couple of phases, we encouraged you to use a website or a tool to generate data. Right? And then we also gave you another website to generate the test cases, csvconverter.com or something like that. Right? Guess what? It not only converts to XML and JSON, but it also converts to SQL statements. Right? So you can reuse all of that stuff basically. Or you could probably even take your CSV file and cut and paste it into Workbench somehow, and then it'll generate the SQL code for you to insert that data. But in any case, you don't have to do a lot of work to get some test data in there. You should check for uniqueness and constraints. Check and uniqueness constraints can be used to enforce data integrity. Remember over here, we did that to ensure that the ownership was unique. You can have person ABC own account 123, but then you can repeat that data and have a person ABC own account 123, person ABC own account 123, right? Why repeat that 3 times? We made sure that the combination of these 2 foreign keys was unique. Do you remember how we did that? Constraint, unique pair, and then we put those 2 into a unique constraint there, like there. Right? You can also go unique key if you're going to search by that combination, but it might be actually the same thing. Right? In any case, there you go. That's a uniqueness constraint. So you can put those in when it makes sense. Any questions on that review of what we did? No? Then remember that we do our online, so if anybody, let's see, I'm wondering. Right, there are at least 2 other people online, so if you have any questions, go ahead and post to the live stream. Normalization, database normalization. So there's first normal form, second normal form, and third normal form. And you know that you've got a good database design if it's all 3 of these forms. And in case you're wondering, there are higher order forms. There's Boyd-Cod form or Cod-Boyd form, I don't remember. And then there's 4th normal form and maybe even 5th normal form. You're not going to need them, Yagni, right? So they build on each other. You cannot have a higher normal form without the lower normal forms. So you first have to have first normal form, and then only then can you have second normal form. And you can't have second normal form if you don't have first normal form and third normal form as well, right? So what is each one of these? Well, the first normal form is that each attribute in a table only has atomic values. Right? Atomic values meaning that each column in a table represents one piece of data or one value. Right? It's helpful to think of these things in terms of the violations of first normal form. For example, one violation would be if you stored multiple emails in one column delimited by a comma, for example. Right? That takes you back to the world of CSV files. Right? The whole point of writing a database is so that you can have normalized data. You don't do that. Instead, if you've got multiple values, you split them out into another table and define a one-to-many relationship. You don't put that into one column and then here's the first email, comma, second email, comma, third email, comma, right? That would be a violation of first normal form because it doesn't hold a single value, it holds multiple values. Another violation, if you stored a fixed number of values. For example, if you did email 1, right? Email 2, right? Email 3. Right? When somebody's starting programming, right, this is what they usually do. Variable 1, variable 2, variable 3. But you immediately get away from that bad habit like in the first or second week, hopefully, right? Why go back to that bad habit when you're doing databases, right? Now, there are some cases in which this might make sense. For example, you're never going to have cause to support like 50 different emails for one person, right? Maybe you only want to support one email, in which case, yeah, if it's just a one-to-one relationship, forget that other table. If you want to support a primary and a secondary, maybe that's another argument for not having a second table. And then that relieves you of the need of doing a bunch of joins, right? But it's if you're going to have 3, 4, 5, right? Unless there's a very good reason, right? GR, right? All caps there. Then you should still normalize this out into its separate table, right? So again, the good practice or best practice is to separate out into another table and define a one-to-many relationship. Separate. There we go. All right, so what is second normal form? Second normal form. Second normal form is where you've got first of all, it has to be first normal form. Again, the lower order forms must be satisfied before you can satisfy the higher normal forms. So it has to be one normal form, but also no non-prime attribute is dependent on a proper subset of prime attributes. Now that's difficult to parse. And that's why I tell you, make sure that you always have a primary key. Having a primary key auto-incremented gives you to normal form automatically. Right? You will never have a situation in which you don't have second normal form. So again, it's helpful to think of these things in terms of, for example, violations. So let's go ahead and take a look at this violation. Suppose that you have, hint, a customer ID, a store ID, and a store address. Right? The store address is not dependent on the customer. It's only dependent on the store ID. So if you defined a primary key as a combination of customer ID / store ID, then you violate second normal form, right? The store address only depends on the second half of the key. So this really only comes up if you've got compound keys, keys where it's multiple values. Now again, sometimes you want that. For example, over here, remember that person ID and account ID? We made that into a key, but it was not our primary key. Right? Our primary key was automatically generated by the database, that ownership ID right there. And that's why it's easy to get second normal form. All you have to do is follow best practices. Right? So it's basically the solution here is to, it is often useful and necessary to define key combination keys, but you keep them as secondary, not as primary. And then you split everything out into its own table, right? It's kind of intuitive once you get the hang of databases, right? Third normal form is that it has to be second normal form, and therefore by transitivity, first normal form. So transitivity, remember, is A goes to B, B goes to C, therefore you can go from A to B. How? By go to B first and then go to C, right? So it has to be first normal form and second normal form, and the definition here is that no non-prime attribute is dependent on, it's transitively dependent on the key. So again, let's take a look at our example over here. What is the value of an annuity account? It's the monthly payments times the number of years times 12, because there are 12 months in a year. We clearly store the monthly payment and the term years in our database. What did we not store? That total value, right? So that would be a violation. So a violation would be to store the term years, monthly payments, and store the total value, right? Which is equal to the term years, here I'll put it in code, term years times monthly payment times 12, right? Now why would you not want to store that? Because it's derivable from the other two. If you store term years and monthly payment, you can always recompute the total value just using those two pieces of data. That total value is behavior, it is not data, right? It is a result of two other pieces of data. And if you end up doing this, right, it gives rise to possible data anomalies. Did I spell it right this time? Nope. O-A. I always get those wrong. Yeah. So if you change the one value, it means the third value, the transitively dependent value is now wrong. Right? So for example, if I've got a monthly payment of $100 and I'm going to go for 5 years or 60 months, right? That's going to be what, $6,000, right? Something like $6,000, yeah, $6,000. But if I change that monthly payment to $150, that $6,000 number is now wrong, right? But it's being stored in my database. It's stale data is what we call it. So don't do that. Storing data that is dependent on other data is wrong. It is a violation of, not wrong in the moral sense, but it's wrong in the third normal. In that it's a violation of third normal form, right? So just remember this mnemonic device here, right? That every non-key attribute, in other words, every column that's not a primary key, must provide a fact about the key, first normal form, the whole key, second normal form, and nothing but the key, so help me, third normal form, so help me God, right? So I swear to tell the truth, the whole truth, and nothing but the truth, so help me God. This is a mnemonic device that lets you remember the three rules of database normalization, right? Everything has to be provide a fact about the key, so every value has to be atomic. The whole key, it can't just be partial. If you've got a combination key here, that it can't just be partial, it has to be everything, right? Both parts. And nothing but the key. So again, using or storing that third value, that total value, is wrong because it's derivable from the first two values. So help you COD. Who was COD again? Yep, the guy who came up with it, Edgar Codd, 1970. I'm pretty sure he's still alive. How do you look that Edgar Codd? Wikipedia. I'm sure that if he, yeah, okay, never mind. He was 80 years old. He died in 2003. So, yeah, he's long gone. All right. So there's a lot more that we could cover. Again, this is one module of one course, right? There's a lot more. For example, triggers, right? This is not a database course, so we're not going to go over every single detail to make you into a DBA. That would probably be like 2 or 3 course sequence if you wanted to specialize in database stuff. But you've got triggers, which are event-based actions in a database, right? So for example, I've used triggers before such that anytime somebody logs in, I will update a column in my database with a date time stamp that's the last time that they logged in. Or they change their password and the password is being stored in the database. That's not a great idea, but it was the last time that data was changed or something. So that what you can do is you can set that up automatically. When that column over there in that table gets changed, update this column over here to have a timestamp, right? Or you can do anything that you want, right? When that event happens, that event over there happens. In fact, this is permeated into mainstream. If this, then that. There we go. So it's just an if-else-if statement, or if it's an if-then statement, right? IFTT, connect your apps. When somebody replies to my tweet, then go ahead and email me. Or you can set these rules up and it'll take care of it for you, right? Is there an example here? Come on. You're not even selling your stuff by giving it, create an event on your iPhone's calendar with, I don't know. IFTT stands for if this, then that, right? So you can just set up, without knowing any programming basically, you can set up an app that, set up a rule that, I don't know, when I post to my Facebook, I also send out a tweet telling everybody that I posted, right? You can set up rules like that. And that's basically what a trigger is. That when something happens, then you define something else that then happens. Say what? Yeah, it's just a web interface because certainly you could do an API, but that website is aimed towards non-programmers, right? People that just want to set something up for all their social media or whatever. Right? Another thing that we're not going to cover are views, right? These are read-only tables in a database, right? So if you don't trust your app to not screw up your data, you can give them a read-only access. And so yeah, okay, you're going to load up the data and display it, but you're never going to insert data, you're never going to update data, you're never going to delete data. I'm going to save myself from the possibility that you do those things and that you do them wrong by giving you a read-only access to that table. Another use case would be if you've got, say, 4 columns in a table and I want to give you access to the first name and the last name, but not all that other information, like, say, salary or social security number, I can create a view that only gives you access to those first 2 columns. It's not a real table, that's why I say tables, right? Because what you do is you define a query and then you grant access to it, and it looks like a table that you can query out of it just like a normal table, but it's a read-only fake table. Right? In fact, there are other fake tables called temp tables. Right? Temporary tables, temporary tables that can be created within a transaction to make data processing easier, right? So for example, if you've got like a really big query and report that you want, you can say, oh, I'm going to take that data from that table, put it in this temporary table, take that data and put it in this temporary table, and then aggregate it all together. It doesn't actually exist. It exists for the purposes of that query, but it doesn't exist afterwards or before it, right? It just makes your life easier and makes it easier to write some really complicated queries. You also have stored procedures. Stored procedures, right? These are functions you can define with reusable SQL code that you can treat like a function, right? Exactly like a procedural style programming language like C or a single method in Java, right? You can actually define a function that then you can call that function and it'll do whatever you want. Whatever code you put into that function, it'll execute that code. But it's written in SQL. That gives rise to, say, loops, variables, which are cursors, right, etc. Yes, you can do all that stuff. It's not really all that natural in my opinion because SQL is a declarative programming language, which means that these procedural style of doing things, defining a loop and then iterating over it or something like that, it's not really how SQL was intended, right? SQL was intended as a query language for you to declare that I want this result set over here. But you can do loops, you can do variables, which are called cursors, etc. Right? In fact, I saw somebody had obviously had done SQL before, and their submission for one of the labs, they were doing all this fancy stuff, like creating a cursor so that they didn't have to do a nested query. Which, oh, okay, cool. That's a nice use case. If you want to use them, great. If you want to learn about them, great. We're not going to stop you, but we're not going to cover them either in detail. I'm just making you aware of them. You also have transactions, right? An all or nothing, right? Atomic action that can include more than one query. So for example, if you were running 5 queries, the first one went fine, the second one went fine, the third one went fine, but the fourth one breaks because you violated some rule or there's a syntax error or something like that. And then the fifth one doesn't even execute because everything errors out, right? A transaction allows you to take these 5 queries and treat them as one thing. So that if any one of those things fails, it rolls back all the way to the beginning as if none of them occurred, right? This ensures that you've got some sort of data integrity into your database because these 5 things, they need to all happen or none of them should happen. That's a transaction. You start a transaction at the beginning, go, 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 and then at the end, you can choose to roll it back, in other words, undo it, or you can choose to commit it. And over here in MySQL, I think that the keywords are begin transaction. Right? And then I'm going to do all of this or none of it, and I will commit that transaction, or I will roll back that transaction. Right? So undo or, yes, everything went well, so I need to commit that now. Again, it's something that we're not going to go over in detail. Right? Another thing, I think I've mentioned this before, but we'll go ahead and talk about it again since we had an entire break. Soft versus hard deletes, right? Where if you use a delete statement, that data is gone, period. There's no undo. You can have a database backup and then load data from that database, restore data from that database backup, but otherwise a delete statement is final, permanent, right? That's called a hard delete, when something actually gets, is deleted from the database and not recoverable. A soft delete is where you define a column called, say, is active, right? And it's a Boolean, it's true or false. It's true if the record is active, false if it's deleted, right? So I put that in quotes there because it's not really deleted, is it? That record is still there, it's just that is active is false. So when you go to query something out of the database, you only query the results that are active is equal to true. That way, it looks like it's deleted from the front end or from any queries that you run, but it's not really deleted. So that when somebody says, ooh, I accidentally deleted that stuff, can you restore it? You know, you take your time and you come back and you're the hero because all you did was set is active to true again. It was never actually lost, right? So if you want to use soft deletes, hard deletes in your project, go ahead. I would say that that falls under YAGNI. You ain't gonna need it, right? All right? But in a real system, I've often done this just as a safety backup kind of thing. Also remember that there is a difference between the object-oriented programming model and the relational model. We've talked about this before, so I'll go ahead and just bring it in here. The OOP model allows inheritance and behavior. In other words, methods. Oops, got a question online here. Would it be worth it to save computable value to save compute time? Save a computable value to save compute time? Only if it's extremely expensive. So this probably goes back to the third normal form where I said don't store that total. One value times another value times 12 is not at all difficult to do, right? There's no computation time there at all right? So know that you would not want to store that. Now, connecting to, and this is an actual example that I've done before, connecting to an API to get the driving distance from one location to another location, right? And that API, Google Maps, right, charges for every query that you make. Yeah, I'm going to store that, right? I'm going to store that in the database because I don't want to pay them money to compute that driving distance again. So if it's expensive, right, computationally or actual dollar value expensive, then absolutely go ahead and store it. But the use cases for that are far and few, far and in between, right? Anyway, the OOP model allows for inheritance and behaviors, in other words, methods, right? Our DBMSs, the relational database models, do not have inheritance nor behavior. Right? Now you can, again, like I just said, you can define functions, you can define stored procedures in SQL. You should use them very, very sparingly. Right? If you're a DBA, you do that all the time, but if you are a middle tier programmer or a front-end programmer, you don't want to be doing a lot of stored procedures. Why? Because it puts your business rules into the database, and then that forces data to go into the business section. You want these things to be separated, right? You don't want every DBA to be a middle tier programmer, and you don't want every middle tier programmer to be a DBA. Now, companies will want that, right? Companies always advertise for a full stack developer. That should be a huge red flag. Why? Because they only want to hire one person to do the job of like 3 or 4 or 5 people, right? So, you know, be wary of full stack engineers or full stack, you know, superhero, or what do they call them? Rock stars, that's it. That's the buzzword. We want a full stack engineer, a full stack rock star to do all our stuff. No, translation, they only want to pay for one person. All right, so you need a way to resolve the differences between these two models. You can create a table per class, for example. You could create a table for annuity, savings, and account. So you could create 3 tables. Or you could create a table per subclass, right? And only have, say, an annuity table and a savings table, right? Or you could do what we did and use a single table inheritance strategy. One table that represents all subtypes using a discriminator column to tell the difference between them. And that's what we chose to do over here. We've got our type here, which is varchar1, A for an annuity, S for savings. And then we've got our monthly payment and term years, which are relevant to annuity, but they would end up being null for savings accounts. And vice versa here, balance and APR, they would end up being defined for a savings account, but null for annuity accounts. Right? And that's what we suggest that you follow. Just use a single table inheritance strategy. If you've got a lot of subtypes, if you've got like 5, 6, 7 subtypes, maybe then you have an argument to go with one of those other strategies. But with just 2 subtypes here, or 3 or 4 subtypes, why complicate it, right? Just make it simple. Keep it simple. You use a string to indicate which subtype it is. Some columns may be relevant to some subtypes, others will be irrelevant. You simply allow them to be null. Right? Okay, any questions on database design? No? Then let's think about how we've been interacting with our database up to this point. We've been doing everything in MySQL Workbench, right? I've been doing it interactively. I run a query, I see the results, right? That's not what data is about. Data is about automation, right? So what we need now is a way to programmatically, say, write Java code that connects to our database and then processes data for us, right? I want to programmatically connect to my database and process data. So that's where we're going next, right? We're going to programmatically connect to a database and process the data, right? In Java, that means that we're going to be using Java's database API, connectivity API. So for the rest of the day here, I'm going to get you started, right? JDBC stands for Java Database Connectivity API. API stands for Application Programmer Interface. The first step is to download and install Connector J for MySQL. That means that you are going to search for Connector J, download, right? And when it comes up, there we go. Dev.mysql.com is where you're going to probably go. Right? And basically, this follows the dependency inversion principle that we talked about with respect to the solid principles, single responsibility principle, interface segregation, solid, SO, open-close principle, Liskov substitution principle, I would be the interface segregation principle, and then finally D, the one that's relevant here, dependency inversion. In other words, we're not going to write code to connect to a MySQL database. We're not going to write code to connect to a Postgres database. We're going to write code to connect to an API, right? That's JDBC. And then this connector J is going to be responsible for taking care of all the details for us. We've inverted the dependency. You can download either a zip file or a tarball. If you don't know what a tarball is, then stick with the zip file. Do not sign up, do not register or anything. Just say, no thanks, I'll start my download here. When you download it, you'll get, eventually you'll get a zip file. Slow internet today. Right. When you open it, it's going to look something like this. Right. It's going to have a bunch of metadata files, but that's what you're looking for, that jar file right there. And the current version as of this recording is 8032. Okay, that should be okay and that should be good. If we run into any problems, of course, I'll go ahead and make sure that you've got a version that works. So let's go over here to Eclipse. I'm going to go ahead and close most of this. And how do we bring in an external library? You've done it before now on at least several, hopefully you did it on like the first phase. But let's go ahead and create a lib folder, lib short for library. Right? And let's bring over that connector J jar file here. Drag, drop, copy files, great. And once that's in there, right click, build path, add to build path. There. That's all we need to be able to connect to a database now. So let's go ahead and start. Right? So there are going to be several steps to this. The first step is to make a connection, okay? So one, create a connection to your database. Right? You need a username, or a URL, a username, and a password. So let's go ahead and put those into variables immediately here. String URL equals. This should look very familiar, by the way, right? Over here in MySQL Workbench, let me go ahead and close this. No, I'm already connected, so let's go ahead and quit this. And let's go with MySQL Workbench. Right. And if you've already created a connection, it looks like this. But when you went to originally create the connection, what did you need? You needed the host name, which is the URL. That's going to be cse.unl.edu. You need a username. You're not root, you are you. I am me. Right? And then, of course, eventually, it's going to prompt you for a password. Those are the exact same things that you need to connect to your database over here. You need a URL, which technically is going to be cse.unl.edu. We'll come back to that in a second because you're going to need a lot more than that. You will need a username, and it's going to be me. Right? You'll, of course, need to change this. And you'll need a password. This is why we told you to not use a password that you care about. Because either if you're working with somebody, they're going to see this, this password plain text. When you go to hand in your code, you're going to be storing this in code. We'll talk about better solutions at the end. But for now and for your project, you're going to be storing this password plain text in your Java code. We're going to see your password. Right? That's why you need to make sure that you're not using something that you care about. I don't care about this password, CS2. There's my password. Okay. Now that URL needs some work. Let me go ahead and cut and paste this because there are special configuration things on the CSE server that you need to get around. So here's the actual URL you need. Go ahead and copy that down. Don't bother copying. So, yeah, it was a bit long. Don't worry about copying that down. We'll go ahead and provide that. Right? But otherwise, if you want to read about this, there's the protocol. If you went to a website, the protocol would be HTTP or HTTPS. Right? This is not HTTP. It's MySQL, JDBC. Otherwise, we're connecting to cse.unl.edu. I'm connecting to my database. You'd need to change that as well. And then we've got a whole bunch of configuration stuff here because of UTC time, Universal Time Code, or Universal Coordinated Time is what that stands for. Right? In other words, Greenwich Mean Time. All right, so I've got my URL, I've got my password, username, and I've got my password. Now I need to actually make the connection. Right? So connection, con, is equal to, I'll just go ahead and say it's null first, and then bring this in. Is this a MySQL connection? Is this a Postgres connection? Is this a SQL Server connection? The answer to all those is no. It is a generic API connection. It is something that represents a connection to a database. It doesn't matter if it's a database that's a SQL Server, MySQL, or Postgres. It is just a connection. Right? And you'll see here that it's in java.sql, right? The SQL library. To create that connection, I need to ask the driver manager, right, to give me a connection based on the URL, username, and password. There we go. All right. Now it's complaining about this because unfortunately my JDBC is quite old. I mean, it's still used, of course, but it goes back to, I think, Java 2. This was back in a time when, do you remember checked exceptions and unchecked exceptions? Checked exceptions are one that you have to surround with a try-catch, and that's what happens here. I'm going to go ahead and surround this with a try-catch. I'm going to go ahead and try to make this connection, and if anything fails, then an SQL exception occurs, and I need to handle it. I'm forced to handle it. Well, what if I don't have the correct password? Can you reasonably recover from an invalid password? Not really, right? Can you reasonably recover if the server is down? Not really. Right? So I'm going to, remember being an angler, you catch and release. I'm going to throw a new runtime exception, wrapping up E, and then just let it take care of it. Okay. Let's actually go ahead and try this now. Remember, that's my bad password. When that occurs, access denied using the password, right? Okay, let me go ahead and fix that password and instead have a bad URL. CSCFD, right? Yeah, there. No communication link failure. It went out to the DNS server. There's no such thing as cscfd.unl.edu, right? Or at least I couldn't find it. It immediately, donks out of it. Otherwise, if you get everything correct, run this, then it's fine, right? Except that, guess what? I opened up a connection, right? When you open up a file, what should you make absolutely sure you do? Close it. Now, a connection to a database is even worse, right? Because it's not just a file on the local system. You have opened up a network connection to a remote server, and that network connection could be open right now, right? It's probably not. It was probably automatically closed. Cross your fingers and hope that that's true. But you are limited to, say, I think 30 connections at once. So if you open up a connection, don't close it. Open up a connection, don't close it, and open up 30 of them, and then you try to open up the 31st one, it will fail and your program will crash. I think on the server, if you open up a connection and then you don't do anything with it, it times out after 5 minutes. Right? So you might be stuck there if you don't close your connections, waiting for all the connections to be automatically closed by the server. Right? A connection to a server is actually a really expensive thing, right? Because network bottlenecks, the amount that you have data that you can send over the network, that's typically your bottleneck for all computation. Right? You can have we have the fastest processors in the world right now. Right? I've got an i9 on this computer. My bottleneck is going to be getting stuff from the actual network because that's the slowest. Right? In fact, to this day, what is the most efficient way of transmitting data from place A to place B? Manually how? Take a flash drive or a hard drive or whatever, right? And then physically going over somewhere and plugging it in, right? That is still the least expensive, fastest way to get data from point A to point B, right? There are no network connections that can beat that, right? I could have a truckload of hard drives, ship it across country, and set everything up and plug it all in before you could even send like a fraction of that data, right? So the speed of light is not always the speed of light, right? So let's make sure to close our connection, right? So 1, open up the connection. And the last step here is, do I have numbers? I forget how many numbers I have. Yeah, I'll go ahead and go with 4. So 4, I'm jumping ahead here to the 4th step, close your resources, right? Connections, etc. So I'm going to go ahead and say con dot close, except that I need to move it out here. There we go. Is equal to null, con is equal to that, and then con dot close, the connection dot close. Now it's complaining about this again. Why? Because everything that you do in JDBC has a checked SQL exception. Oops, that's not what I wanted. Right? Undo that. I have to surround everything with a try catch. Now you can go ahead and use this strategy that I'm showing you right now. Each and every single line that needs it, you go ahead and try, catch, throw, try, catch, throw, try, catch, throw, right? Or you can go ahead and put everything into one big giant try, catch, throw statement, right? What you choose to do is up to you because again, there's a design flaw from 25 years ago where they thought that checked exceptions were just awesome back then. Again, in the intervening 25 years, there's not a single damn language that I know of that has adopted this feature. Right? It seemed like a good idea at the time, but it wasn't. Right? And so how you choose to handle this is up to you. If you want to be fine-grained and do each and every single block of code in its own try-catch, like I'm doing right here, or if you want to do it in one big giant one, that's also acceptable. I'll go ahead and keep them separate though for now, okay? So I've got my connection, I close it. Here, I'll show you that it actually works. Yep, great. If you want to start logging stuff like connecting, ... closing, ... we'll talk about a better way of doing that later on, but we won't do that for now, right? So my second step here, right? Create an SQL query to submit to the database. To do that, we use what's called a prepared statement. There are other types of statements. I will not even talk about them until we get to the end where we talk about SQL injections, but do not use them. So what I'm going to do is I'm going to select, string query is equal to. I've got a bunch of data. Remember I changed my password, so let's go ahead and do this. There we go. Open foo. Where's foo? Come on, really? All right.
It's like you have to open it's like a file, open SQL query file or script.
Open SQL script. Okay, there we go. Thank you. And foo.sql, there it is. All right. So I inserted a bunch of data here for persons and emails. So let's go ahead and start that. I want to go ahead and get all the persons out of this database. There's Grace, Alan, Margaret, and Donald, right? Famous computer scientists. In fact, does everybody know who they are? Grace Hopper, She was a rear admiral, a pioneer in a lot of computer engineering stuff. Alan Turing, known for Turing machines and breaking the Enigma or helping to break the Enigma in World War II. Margaret Hamilton, I think she coined the term software engineering, worked on the Apollo missions, that worked on the computing systems for the Apollo missions. And then Donald Knuth, he's famous for having these 5, or I think 4, eventually 5, he wants to get it done before he dies, these huge volumes on computer science. And so he's also the creator of LaTeX. Do you use LaTeX in your other courses? You do? Okay. So blame Donald Knuth if you want, or thank him, because he didn't actually create LaTeX. He created tech, and then people made LaTeX after. He was famous for offering like checks for finding bugs in tech. So if you reported a bug, he would send you a check for I think $3. It was conversion on Pi, I think. So it was something like $3 for the first one, 10 cents for the second one, it was something like that. I don't remember what it was. Or maybe it was going up. $1 for the first one, $2 for the second one, $4 for the third one, or whatever. You never actually wanted to cash those checks because you had a Donald Knuth check. That's worth way more than the money he actually paid you. But anyway, you can read about the details of that because I forget what they are. We've got 4 people here. I want to pull them from the database. So if I were to do this over here in MySQL Workbench, in fact, I would suggest that you write your queries in MySQL Workbench before you take them over to your Java. Select everything from person. There we go. If I did that, oops, use CBERT. You don't have to use, say use in JDBC, but you do over here in MySQL Workbench. There we go. Select everything from person. There is my query that I'm going to go ahead and bring over here and put into my Java code over here. Now, strictly speaking, you do not need a semicolon here. In fact, I don't usually put them there because I get confused between that semicolon and that semicolon, right? But this is a string. Now, some people like to go old school on this, right? Over here in MySQL Workbench, I used everything lowercase here, but that's because I have syntax highlighting, right? I know I can see from the blue that select and from are keywords in SQL. Over here, you don't have that luxury. You might have an IDE that does have syntax highlighting for SQL strings within a Java environment, but you don't have that here. So some people like to go old school and make sure that all of the SQL is all uppercase like this. I'm not one of them. I don't get that easily confused. Right? I get easily confused on other things, but not that. Right? So go ahead and keep it like this. Right? Or choose to do the other way. Just be consistent about it. Now that I've got my query, I need to prepare a statement with that query. So we use a prepared statement. And I'll just call it PS for short. And my connection is going to prepare that statement for me. Prepare statement. There we go. From my query. I need to make sure that this is imported. But likewise, this is going to force me to surround this with a try-catch. So yet again, you can go ahead and put this in one big giant try-catch, or you can go ahead and separate each thing out into its own try-catch. There. What's a long name? Oh, it's reasonable. There we go. If you want to, you can bring your query up here too, right? And then only what needs to be within that try-catch, you put it down there. Okay. So I've got my prepared statement. Now what I need to do is I need to execute. So prepare your statement, 2A. Prepare your statement. And we'll talk about prepared statements in more detail on Thursday because the reason that you want to prepare your statements is so that you can escape certain sequences. For example, if I had, say, single quotes in here, right, that's not going to be allowed. So those need to be escaped into, backslash quote, backslash quote. Don't do it yourself. Let JDBC do it for you. Right? Execute your query. So that's going to give me what's called a result set. I'll go ahead and go with result set rs. And rs is equal to ps.execute. There we go. Execute query, sorry. Query. There. All right. That result set is built into the JDBC library here. So now we have three generic ideas of connecting to a database. You need a connection. You need a statement. You need a query, something that represents a query. And then you need a result set. The result set over here in MySQL Workbench was given to you as this grid, right? There's the result set. But over here, we need a way of representing that in code. And that's going to be with this result set class right here. Now what I'm going to do is process the results, right, or result sets, right? And the way that I'm going to do that is simply iterate over it. So I'll show you how to do this with a while loop. While rs.next, what I'll do is I need to pull the individual fields or columns from the current record, right? There we go. And so what I'm going to do is, what is a person again? A person is a person ID, a first name, a last name, and a date of birth, okay? So I'm going to go ahead and pull those things, each one of those things. An integer, because it's person ID, right, is equal to rs.getInt, right, person ID. Right? A string is the first name, rs.get first name, or .get string first name. How am I remembering all this, by the way? Last name is equal to rs.get last name, or get string last name, because I followed good naming conventions, right? There's no guesswork here. If you want to get the ID, the last name, the first name, I'm querying the person table, so it's called person ID. First name, last name, they follow consistent naming conventions, and so there's no guesswork here at all. And then finally, the date of birth is also a string. The date of birth is equal to rs.getString, and that's date of birth. I'm naming all of my variables exactly the same as my column names so that I don't have to think about this, okay? Let me go ahead and run this and show you that it actually works. Oh, well, I'm actually not doing anything with it. Let's go ahead and go with system.out.println or printf, %d, %s, 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 and the line. And what I'm going to do is I'm going to do the person ID, the last name, the first name, and then the date of birth. There we go. And now let's run this. And we'll see here that we get the exact same result set as we did over in MySQL Workbench. There's Grace Hopper, there's Alan Turing, there's Margaret Hamilton, there's Donald Knuth. 10, 20, 30, and 40. 10, 20, 30, and 40. Right. Now let's go over how that actually worked. Okay? So I prepared my statement, I executed my query. I'm getting back a result set right here. Right? That result set is a bunch of rows and a bunch of columns. So the way that you process that is you iterate over each row. Now initially, there is a cursor, and think of my cursor right here on the screen as pointing to before the first record. rs, result set dot next, will advance this cursor to the next one. In fact, think about that little black arrow there as your cursor. Initially, right, it's before the first record. Then when you go to the next record, it's there. When you go to the next record, next record, next record, what happens when I'm at the last record and I go to the next record after I'm done? Is there any more records to return? No. Nope. And that's how this while loop is working. While I'm going to advance to the next record and it's going to return true. You're pointing to a current record. Here are my 4 records. Next, it's pointing to a valid record, true. Next, true, next, true, next, true. The last one that you do, next, returns false, and you break out of this while loop. And that's how that's how this is working here. Okay?
So it's like a file?
It's basically like a line-by-line file, yeah, exactly. And for each one, you execute this. So I'm at the current record right now. Now each one of these lines processes a column. So I'm at one record, there are four columns in that record, first column, second column, third column, fourth column. Right? And that's how you go about processing this stuff. Again, running it, there we go. We can go ahead and insert a new person, 50. Joe Smith. And these are actual dates, so I want to keep them as actual dates. Oh, here, Joe Unix. No, what? Unix. When was Unix, when's the Unix epoch? 1970, 0101. There we go. There. And I'll close this and I will commit it, apply it, apply. There we go, close. When I come over here and run it again, I now get Joe Unix. This is a string representation, but of course we could have done it a different way. Local date, date of birth, and I'll rename this as str for string, is equal to local date dot of, or is it parse? Dot parse. Yeah, and that's that string. There we go. Right. You're marshalling it out of their database and parsing it just like you would a file, and then you're parsing it out of the file. And date of birth, there we go. So let's see if that works. Yep, exact same results, because that's how the two-string method works. Right. Any questions so far? Well, that seems so useful that maybe we want to put that somewhere. Maybe a function, right? So that loads up all the people from the database, right? And instead of printing them out, maybe we put them into a, return a list of people, right? Result.add person. So let me come back up here and let me modify this so that we have a list of persons, right? People, or everyone, is equal to new array list. There we go. And bring these in. Import everyone. Everyone.add this new person P here. But I need to create that person. So person P is equal to new person. And I forget how to create a person, so let's take a look at it. First name, last name, is that it? That's my only constructor? Oh well, first name, last name. We'll just ignore first name. Say what? Right. There we go. And then I will return that, that list of persons. And I'm going to put this into a function here in a second. But what I wanted to do is highlight a difference now. Now that we're loading up from a database, we've got new stuff. Right? Over here in my original person class, did I have an ID? No. An ID was, how did I define ID? If they had the same last name and the same first name. But now that this is database, now that it's backed up by a database, maybe I have a different notion of what it means for this person to be the same as that person. And so I need to maybe go back and private int person ID. Why did I make it an integer? Because that's what it is in the database. Why did I call it person ID? Because that's what it is in the database. Right? And let's go ahead and add this to our constructor now. It might break some other stuff, but so be it. This dot person ID is equal to person ID. There we go. And maybe you want to go down here and rewrite some stuff so that you're printing it out along with the first name, last name. Maybe you want to change how you're comparing the stuff, your hash code and your equals method here, to not be based on the first name, last name, but now to be based on the database ID instead. Right. So there might be some refactoring here. Person ID. There we go. All right, so let's take all of this and put it into a function. I'll put it down here. Public static list of person load persons. Right? Seems familiar, right? Instead of loading persons from a CSV file now, you're loading it from the database. Load persons from database. If you thought prepared statement was long, that's long too. Right? quickly, right? There we go. Don't write that. Load persons, right? And this is where your object-oriented programming comes in handy, because if you had a good design in your first and second phase, right, and where you're loading from CSV files, that means you've got this class over here that's doing all the work. All you need to do is create this different class over here that mirrors the interface of that class over there that does it from CSV files, but this one now does it from a database instead. Right? And then switch over your other code that instead of using that class, use that class over there. And you don't have to change a single line of code anywhere else. Right? Well, do you have a data loader class? Right?
Yes.
Okay.
I don't have
A what?
I don't think I have an interface.
Well, an interface is nothing more than its public methods. So you have a data loader class, load people, load items, load whatever, right? Now you have a different data loader class, a database data loader class. And then maybe, well, what's the difference between these two? We have the same exact interface, except over here it's loading from CSV files, and over here it's loading from a database. Maybe I'll go ahead and create an interface, dependency inversion, and go back and change my code that instead of hard coding it to that one data loader file over there, I say there is a generic interface of a data loader, and I say that one for phase 1 and 2, that one for phase 3 and beyond. Right? You won't have to do JDBC yet until after you design your database, of course. Right? So let me go ahead and put that all in and return every one. There we go. Now up here in my main, I'm simply going to call that, right? List of person, right? People is equal to load persons. There we go. In fact, you know what, we've got, here, let's go ahead and system.out.println people to make this explicit that it works, right? Great. But now let me go ahead and explicitly do what I was talking about here, right? Let's go ahead and make an interface. So new interface, right? Data loader, right? That interface, anything that implements that interface is going to have, say, a public, can I do static? Static load persons. There we go. Oh, and then of course your list of person, there we go. And I'm going to have to bring all that stuff in. Import, import the list first. Import, there we go. I don't think I can have static methods here. Okay, fine. Well, everything is abstract. I don't think static functions can be abstract though. So what we'll do is we'll just go ahead and make it like this. All right. Now let's come over here and create a new class. I don't know, CSV data, CSV file data loader, or CSV file loader. There we go. And that implements the data loader. Right. There we go. Now to do that, you're going to have to implement that load persons. There we go. You've already written this code. You just haven't put it into a function that looks like this, right? Now let's come over here to the, and create a database data loader. Database loader. And we'll do the same thing over here. It implements data loader. Oops, that's not what I want. And let's add that unimplemented method. But we've already written that. It's over here in this demo class over here. I'm going to go ahead and steal it. Move it over here. Done. Reformat everything automatically for me. Okay. Great. Now over here in my demo class, what do? If I'm in phase 1 and 2, I need a data loader, data loader, DL, right, is equal to new CSV file loader. And now you can go ahead and grab the list of people, list of person. You know what? I don't want to retype what I just did. So there we go. Data loader, dl.loadPersons, right? Now what do I need to do if I'd followed, if I'd had this framework, looking ahead and had this framework from phase 1? What do I need to do now to switch it over to reading from a database data loader? Database loader. Do I need to change any other line of code? Nope, because it's a common interface up here. Right? So, run that, great. CSV file, of course. CSV loader. What did I call it? CSV file loader. Right? Now, obviously, it's not going to do anything because I didn't implement it, but you've implemented it already. Right? And now think about this. Now that you've got this, this is dependency inversion, right? This is that D of the solid principles. Now your code does not depend on loading it from a CSV file. It doesn't depend on loading it from a data file. You've made it more generic. It can load from anything. It could load from XML files, right? All you need to do is write that class. It could load from JSON files. All you need to do is write that class. The only thing that needs to change over here is your instantiation. All this code down here, say that there was another 300 lines of code that depended on loading persons, right? Nothing needs to change.
Depending on what the range you are, you can make it load from a PDF.
Actually, I don't know about loading from a PDF, but I used, what was that package I called? iText, is it? iText. Yeah, it's iText.pdf. So writing Java code to generate a PDF on the back end so that you can produce a report. And it's not that crazy, right? PDF is just a way of representing something. You could load from a PDF, theoretically, if they had written a good PDF, but you could do that. I've written code. This is our grad system many, many years ago before they got rid of it. I wanted a way that because we still had, lots of faculty that wanted to, read a PDF or print it out or something like that. And instead of having all the data on graduate applications in a computer, right? So what I did is I used this library, iText, to generate a PDF version of their application, right? Because they were turning in their CV, their resume, letters of recommendation, transcripts, all of these all of these files as PDFs or JPEGs or something like that. Then they had information on, their emails and et cetera, et cetera. So we had all this different information, and then I had to collate it all together into this one giant PDF, right? And to do that, I used iText because it was all Java. So it collated it all together using this. So it's not that crazy to load from a PDF, right? Or generate a PDF from code. You do it all the time, right? But again, dependency inversion. You are no longer dependent on how you are loading up the file. You're dependent on a common interface now. Right? So take it or leave it. We're past the phase where we're grading you on OOP, right? So which is why I'm showing it to you, right? By the way, we did not expect this from anybody. Right? This is how I did it, but we didn't expect this from anybody. If you did it in a static methods in another class, great. You'll just switch that over to a new class now. All right, I'll see you in lab then.